using a calculator, and I forgot to write up there, but you're going to round it to 4 decimal places. So if you're to find, and this is an example, you don't need to write down very many of these. Log of 42. Now, if you've got a reverse polar calculator, you put the log key in first and then 42. If you've got a normal calculator, you put 42 in, then the log key. So it depends on what type you have, which I think most of you have reverse polars. Anybody got an answer for me?
1.6232.
1.63.
232.
232? Did I get it right? Everybody come up.
Or it'd be 233.
Does it round up?
Yeah, it'd be 233.
Well, I'll just fix it. 233. If it's 5 or more, you round up. Did you get it?
Oh, 4. Oh, it's a 4. No, no.
It's a 4?
Yeah.
Then it won't round up.
Yeah.
I missed the 4.
You missed the 4.
You went to the next number?
Yeah.
So this should be 6232.
Yeah.
Okay, let's try another one. Does everybody find their key on the calculator they're going to use?
Yeah.
Okay, what if I want the log of 128? Did you find yours? Oh, yours is that different calculator, Spencer.
I know.
Yeah, because we're going to use that in business. I don't see an LMG key. Nope, let me get you one. Now, when we do the business formulas, that's going to be great. And this one's right there. Okay, what you guys get for an answer on
2.1072.
1072? Okay, let's just do a couple short, quick ones. Robert, tell me what the log of 5 is. Don't need to write these down. No, log of 5.
Oh.
Base 10. If I don't put anything, it's understood to be base 10.
697. Oh, 699.
699. Okay, Nathan, what's the log of 7?
0.8451.
Okay. Aaron, what's the log of 9?
0.9542.
Now I'm going to trick you up. Dylan, what's the log of 10?
1.
1. So you didn't have to use a calculator on that one because it is, what base if it's nothing there? 10. So all you're doing on 17 through 20 is doing your log on your calculator. It will not take long to do. Really no work. The next group of problems, 28 through 33 and 42, you're going to be solving. Now, this is why logs are still here. Now, this first one, I don't want you to write it down. I want you to just watch it. We've done problems like this before. What did we have to do with before? Where's my variable? It's in the exponent, right? So didn't we have to get same basis in order to solve? Remember doing that at the very first of this chapter? So is there any way to make 5 and 12 the same base? 5 to the first is 5, 5 to the second is 25. 12 to the first is 12, 12 to the second is 144. There's no way I'm going to end up making them anywhere they're close to having the same bases, are they? That's why logs are still here. If you cannot make them the same bases, then you have to go to log 4. And log 4 means the exponent, remember, becomes multiplied by the log of the base. And if you take the log of one side, you got to take the log of both sides. It's just algebra. If you do something to one side, you got to do it to the other. So now, we've got the log of 5, which somebody told me what it was a while ago. Robert, I think it was you. Was it 0.6990?
That's 6.999.
Yeah, okay. I always put my 4 places, so that'd be 0. I didn't ask anybody. Nicholas, why don't you find the log of 12 for me? And again, 4 decimal places out.
1.0792.
Okay, now what would we do to solve that for x? Divide by 0.6990. Now, everybody to your calculators, what's 1.0792 divided by 0.6990? 1.59? Did I hear that right? Okay, now, again, what have you always learned in algebra? When you get your answer for x, can't you sub it back in to see if it's right? Let's see that. You guys, we used your power key on your calculator before. Put 5 to that power and see what you get. Yes?
When you need to say x is approximately equal.
Yeah, it is approximately.
Make sure.
You round it up to 12.
So do you see that it works? And we only went out 4 decimal places. The more decimal places you add, the more accuracy you would have, right? Okay, now I said you didn't have to write that one down. This next one, let's write it down. Because I did a number on both sides. And this one's gonna take a little bit more work, but it's all just algebra once we get it going. So is there any way to make 3 and 6 the same base? No, because 3 to the first is 3, 3 to the second is 9. 6 is somewhere in between, isn't it? So we've got to do what? If you can't make them the same basis, you go to log, which all of these problems, you will not be able to make them the same basis. Okay, but I'll do an example of one with the same basis so we can do it both ways. So that means the exponent gets multiplied by the log, and the exponent gets multiplied by the log of the base. So exponent, remember from yesterday, goes out in front of the log. Exponent goes out in front of the log. Now you go to your calculator, you find what's the log of 6. And Spencer, what did you get for the log of 6?
0.7782.
0.7782. Notice I put it in front so it makes it easier when I solve the problem. Let's see, Josie, what you get for log of 3?
0.4771.
So all we did was look up on our calculator, which in the olden days, I'd get out that book and I'd look it up on a table. Is the only thing we did different when we did these logs. So we've got the log of 6, we got the log of 3, and now what do we have to do to solve the problem? Distribute. So you're going to have 0.7782x plus 0.7782 equals 0.4771 times 2. Then what would be our next step? All I did was multiply. Get our x's on the same side, so it's just algebra from here on out. So I'm going to subtract 0.7782x. So that cancels. I get 0.7782. All I'm doing right now is subtracting. You guys can do it on your calculator probably faster than I can. I get 0.1760.
0.176. I got 2. Then I put,
I got what she got.
Okay, you got what I got?
oh, I'm put a 2.
You put a 2 in the wrong place. Okay, now what would be the last step? Divide by
0.176.
So that's going to cancel. So x equals 0.7782 divided by 0.1760.
Oh, we'll get a fraction.
4.422.
We're dividing is what we're doing.
Okay, forget
4.4226. Anybody else? 4.4226. Anybody else agree with that?
I got 4.42116.
I got 4.
That's what I got.
Okay, read that one.
Well, let's try 4.4216.
Yeah.
4.4216?
Yeah,
Okay. Now do we agree?
yeah.
Now, what if we wanted to check this?
Okay.
And now it's approximation, which I should be putting approximation here. So 6, and if I add 1 to that, that's 5.4442. I'm doing what you guys are doing. 4216. And 3 to the 2 times this number, so that's 12, carry 1.
Wait, do we have to check that?
8, you don't, I'm just doing this to show you it's gonna work. I think I multiplied right. I took that answer times 2 on this side. Why don't that side over, put that in your calculator and find out what that is to the power, and then Josie's side over, tell me what this answer is. 3.88432 and 6 to the 5.4216.
Two. I got for the 6, I got 16.
You got 16?
16,551.
16,000, okay, remember that, what did you guys get?
16,560.
Okay, so do you see the approximation is there? Okay, so now, the next example, are you guys good here so I can erase this?
Yeah.
We're gonna do it where we have same basis, where I could do it using same basis, but we're gonna do it using logs and see how it works. Let's see, 9 to the 2x minus 1 equals 1/3 to the x plus 1. Now, I realize that one we can do using same basis, and we will. We're gonna use it to prove whether our answer is right or wrong. But we're gonna do it using logs. So this becomes 2x minus 1 times the log of 9 equals x plus 1 times the log of 1/3. You guys agree with the writing there? And some of you guys might like this better. When it gets test time, there's gonna be a section where it says solve. If it's got the same base and you wanna use same bases, you can, but if you like using logs, you can use logs, because it'll work too. Okay, somebody tell me the log of 9.
0.9542.
Times 2x minus 1, and somebody tell me the log of 1/3.
-0.4771.
4771. Anybody else? We agree? Where do you think you're gonna make your mistakes on these problems?
Negative.
Well, not necessarily negatives, but if you put it in the calculator, you might not transfer it onto your paper right.
Those 7s or 9s.
Those are 7s.
Okay.
My 9s have a little circle on them. Okay, now what would we do to solve?
Distribute.
Distribute. So multiply that. I get 1.9084. Multiply this one. And all I did was distribute. We took 0.9542 times 2, x, and then times 1. Negative 0.471 times x and a negative times 1. So everybody agree there? Now what's our next step? Get our x's on the same side. So to get them on the same side, don't we want to add 0.4771? So that's going to cancel. Get a negative 0.4771. I think I added right. 13 kilowatt. We just got our x's on the same side, Nicholas, by adding 0.4771 to this one. It's just algebra, except you're working with decimals.
So you have to like cancel line up, you thought where you might,
It goes to 0. Whatever word you want to use. Now, what would you do to solve for x? So you're going to add this one. So 2.3855x equals somebody double check me on that one and see if they get the same thing.
Yeah.
Okay, and then the last step,
oh, there's nothing else.
0.2.
how I got 0.4771.
You know,
If you add 0.9542 to a negative 0.4771, Cause you had to move this one to the other side to get your variable by itself. What you guys get? 0.2? Anybody else get 0.2? Okay, now, go back. Don't need to write this one down, we just wanna do the same bases.
I can get that.
I'll check yours here in a minute.
Yeah, well, I'll put it up to point.
You get your decimal point wrong?
I don't know.
Okay, change the bases, 9 can change to 3 squared. Move the 3 to the top, I make it a -1, right? So then I have 3 to the 4x minus 2 equals 3 to the -x minus 1.
What were you writing?
I'm doing the same problem, doing it in the same basis, which I said you don't have to write it down, we're just using it to prove whether or not we get the same answer. Now, aren't my bases the same? So we have 4x minus 2 equals -x minus 1. So what would you do to solve it for x? Add the x, get your x's together, add 2, that's 1, right? Divide by 5, and 1/5 is the same thing as 0.2, isn't it? So see, we just proved that it did work out, but we use logs. So if you don't like doing a problem with same base, could you use logs every time? Anytime you got a variable in the exponent, logs will work every time. Same bases only work on convenient numbers. Okay, so that's what you're doing on that middle section. The last section is 45 through 48, is again just going to be use of calculator. You're going to be doing the change base. Remember I said your calculators only do 2 bases. What bases are they? 10 and e, common log and natural log. But we can find the log of a different base by using the change base formula, which I have written over here in your notes. The change base formula, I like to think of as better as the log of the top divided by the log of the bottom, because that's essentially what it is. So log of the top divided by log of the bottom. And this, when I don't write a base, what base is understood? 10. So that means my calculator can do this for me.
How do we get log of 2?
Whatever this goes here. Whatever this number is always going to go here. Whatever this value is always going to go on top. So the large number is the top one, the small base is the bottom number.
So the log of the constant over the log of the base?
Whatever this is going to be on top, yes.
But I guess no log of the base.
Yes, it is, log of 2. Here is the formula. I wrote the formula down for you a while ago. Log of B, base C.
That doesn't really make sense.
It's just a formula. It's like if I say distance is equal to rate times time. That's a formula. This is a formula. You use the formula by substituting in what you want to use. In this case, the B being the top value, the C being the base value. So that's all you do to do change bases. So this, can't you do all on your calculator? So put the log of 7. And I always put equal, and the reason why I put equal is because some of your calculators put parentheses, and then a lot of mistakes are made when people fail to close the parentheses. So if you just hit log 7 equal, divide it by log 2 equal, you'll get your answer. Anybody got what it is?
2.807.
2.807? 3? Anybody else get that?
Well, 4.
It was round.
Get it around to 4?
Yeah.
Okay, and what I want to see on your paper, since this is relatively, just use your calculator, I want you to see the 7, what you had to use to find the answer. So if I want 7 base 2, I want to see this, then tell me the answer. So if I have the log of 12 base 3, how would I set it up into the formula? Over log of 3. Then go to your calculator and tell me what that is approximately. What's the log of 12 divided by the log of 3? 2.2619. Anybody else get that?
Yeah.
Okay, and what is this telling me? What is this? It's the log of 12 base 3 is what you just found. You know, that log we used yesterday in our assignment, I don't remember what it was, log of something base 5. Well, how they found it was using this change base formula. Or used a table, one of the two. Now, here's another one you don't need to write down. What if I want the log of 30 base 4? log of 30 over log of 4. And then go to your calculator, what is that approximately?
2.4534.
3, 4? Anybody else agree?
Yeah.
Okay, now, so going back through it, page 549, due tomorrow, 17 through 20 is just using your calculator. Hit your log key, go out 4 decimal places. 28 through 33 and 42 are solving. That means you solve by taking your exponent times the log of the base, and then you're going to use algebra to get your solving done. And then 45 to 48 is using the change base formula. Okay, questions?